everyone. Today we are going to learn about arithmetic sequences only. And the nice thing about arithmetic sequences is that it is related strongly with linear functions. So they're actually kind of the easier of the sequences to learn about. Before we get started, let's go ahead and factor the following expressions. We have 6x squared minus 35x minus 6 and 64x cubed plus 125y cubed. Please pause the video and factor each of these problems, and when you have an answer, please go ahead and restart the video and we will see how well you did. Alright, let's go ahead and look at the first one. So we have 6x squared minus 35x minus 6, and even though this is the last unit of the year, factoring is still going to be on every single test, so just keep that in mind. So the first thing I'm going to do is I'm going to try to get creative with my values. And I know that 6 is kind of challenging to work with to start, because 6 could either be a 2 and a 3, or it could be a 6 and a 1. So I'm going to just start off by doing a little bit of thinking. I know that I'm going to be working with the values of 6, and my goal is to get a 35. And whenever I think of 6s, like especially when you have two 6s in a problem like this and they're both on the ends, I always think of like 36 being pretty close to 35. So what I'm thinking is that somewhere I'm going to have to go 6 times 6 to give me 36, and 1 times 1 to give me 1. And then if I were to subtract that 1 from 36, I would end up with 35. So I'm thinking that instead of me working with 2s and 3s, I think I'm actually working with 6s and 1s. And so I'm going to break this apart into two parentheses, splitting apart the 6x squared into a 6x and an x. And I want to get a 35, and I know that if I go 36 minus 1 will give me a positive 35, but I want a negative 35. So what if I made this a negative 36? Then that would give me a negative 35, and I would be able to have my answer. So I'm going to multiply 6 times a 6 on the outside and a 1x times a 1 on the inside. And I believe that if I made the x minus, or in between x minus 6, in between the x and the 6 would be a minus, and in between the 6x and a 1 would be a plus, I think we would have our answer. 6 times negative 6 is negative 36, and 1 times 1 is 1, and 36 minus 1 is negative 35. And there is our factorization. So it just requires you to do a little bit of thinking outside of the box for that problem, and that is what Chapter 12 is all about, thinking outside of the box. Let's go ahead and look at number 2. 64x cubed and 125y cubed. This is a sum of cubes. So because it is a sum of cubes, I'm going to break it down into a binomial times a trinomial. In my binomial, I'm going to take the cube root of 64x cubed, and that's going to be a 4x. Then I'm going to write a plus sign, and the cube root of 125y cubed is 5y. Then I'm going to do square opposite product square. So 4 squared is 16, so that's 16x squared. Opposite is a minus. Product 4 times 5 is 20. Then we have x and y. And then square. 5y squared is plus 25y squared. And there is our answer. So hopefully those factoring questions were not that bad for you. And just know that factoring is going to be on your next test. And our final exam is coming up very quickly. So you want to make sure that you feel pretty confident on your factoring skills. So our learning objectives for today is for you to be able to say, I can identify the first 5 terms of a sequence given an explicit rule. So the next few lessons are going to be about arithmetic sequences, geometric sequences, and neither sequences, and you'll be required to write out an explicit rule, which is different than a recursive rule. So just keep that in mind. I also want you to be able to say, I can tell whether a sequence is considered arithmetic, and I can write an explicit as well as a recursive rule for a sequence, given the first few values of that sequence, or given any 2 terms of that sequence. So that's something that we're going to be practicing, which is a little bit different. Now, arithmetic sequences. In an arithmetic sequence, the difference of the consecutive terms is constant. So what that difference means is that you're either going to be adding or subtracting the same number each time in order for you to come up with your next value. That's what a common difference represents. This constant difference is called the common difference, and we denote it using the letter D. So please keep that in mind. Now, D is found by taking the term that you are currently on and subtracting it from the previous term. That's going to tell you what D actually is. So therefore, all arithmetic sequences are linear, and D is considered the slope. So how is this related to linear functions? Well, we know that linear functions can be written in the form of y equals mx plus b. Well, the explicit form for an arithmetic sequence is a sub n is equal to d times n plus b. And that is where your ordered pairs, for any sort of linear function that I've given you so far, has always been x comma y. And our ordered pairs now, when we're working with sequences, is going to be our term position, which is n, comma a sub n, which is the actual value in that position. Now, the b values are exactly the same, and how you find that b value is exactly what we've done the entire year whenever this has come up. We will either be working with y minus y1 equals m times x minus x1, or we'll be working with the b method. Both ways will get us the same exact answer, but this is called an explicit form or explicit rule. And explicit rules, we've worked with explicit rules the entire year. So explicit rules are really not that bad. It's just remembering the difference between explicit and recursive and what each one requires in order to obtain the certain rule. So what we want to do is we want to write the first 5 terms of our sequence, and I'm giving you that we have f of n is equal to 3 times n minus 7. So remember that n represents your term position, 1, 2, 3, 4, etc., etc. So we're just talking about our term position. So the first 5 terms, that means I'm going to let n equal 1, because that's our position. So I guess I'm going to let n equal 1, 2, 3, 4, and 5. So if I were to let n equal 1, that would mean that we would have f of 1 is equal to 3 times 1 minus 7. And 3 times 1 minus 7, that is equal to negative 4. So my sequence starts off with negative 4. My second position, so I'm going to let n equal 2. That means that we're going to have f of 2 is equal to 3 times 2 minus 7. That's going to be 6 minus 7, which is negative 1. So negative 1 is in my second position. So if I were to let n equal 3, that would mean that we would have 3 times, f of 3 is equal to 3 times 3 minus 7. That's 9 minus 7, which is 2. N equals 4. So I have f of 4 is equal to 3 times 4 minus 7, and that's equal to 5. And finally, we have n is equal to 5, and so f of 5 is equal to 3 times 5 minus 7, and that's going to be equal to 8. The work I just shown here is the work that I'm going to be requiring you to show. Show me your thinking. It's not a lot of thinking that you need to show me, but it's showing me that you understand the difference between explicit and recursive. Let's go ahead and look at letter B. Letter B, we want to, once again, identify the first 5 terms of our sequence. So I'm going to let n equal 1, and I'm not going to show this n equals 1 part. You don't need to. I just wanted to show you what we were going to be doing. So I'm going to go a sub 1, that's going to be equal to 2 times 1 plus 1, and that's equal to 2. And I'm going to write down the number 2. And then we have a sub 2, that's equal to 2 times 2 plus 1, that's equal to 5. And then a sub 3, that's equal to 2 times 3 plus 1, and that's equal to 7. And then we have a sub 4, that's equal to 2 times 4 plus 1, that is equal to 9. And finally, we have a sub 5, that's going to be equal to 2 times 5 plus 1. And 2 times 5 plus 1, that is equal to 11. And those are the first 5 terms of our sequence. So it's really not that bad, and it's actually pretty easy for us to come up with our terms of our sequence. You just need to be able to figure out how to identify those terms when you're given an explicit formula as well as a recursive formula. So in letter A and B, we want to be able to tell whether the sequence is considered arithmetic and be able to explain why or why not. So what we need to do is figure out, are we adding or subtracting the same number each time in order for us to get to our next value? So to go from -5 to -3, I'm adding 2. To go from -3 to -1, I add 2. -1 to 1, I'm adding 2. And 1 to 3, I'm adding 2. So in this case, the answer is yes. This is an arithmetic sequence because the common difference is 2. And we are done. Next, we're going from 32 to 27 to 21 to 17 to 10. To go from 32 to 27, I am subtracting 5. To go from 27 to 21, I'm subtracting 6. These two are not the same number, so the answer is no. This is not an arithmetic sequence because there is not a common difference between the two terms, and that's what you would say. This is not an arithmetic sequence because... There is not, so this is not an arithmetic sequence because there is not a common difference between the terms. All right, let's go ahead and look at example number 2. What we want to do is we want to write a rule for the nth term. And whenever you see that language, write a rule for the nth term, that automatically means that we're going to be writing an explicit rule. Please know that. That language, write a rule for the nth term, means that we're writing an explicit rule. I'm going to put stars around this. This is important. If I'm asking you for a recursive rule, I'll actually ask you for a recursive rule. But if you see the language, write a rule for the nth term of the sequence, that means I'm asking you to write an explicit rule. In this case, because we're talking about arithmetic sequences, our explicit rule is going to be in the form of a sub n is equal to d times n plus b. Then we want to identify what value is in the 19th position. So a sub 19 means that we're going to let n equal 19, and we need to identify what a sub n is. So that means we're going to let n equal 19. We're trying to figure out what value is in the 19th position. And then we're going to write a recursive rule, which once again, that means that you need to identify your first term and tell me what that value is. And then you're going to write a sub n is equal to, and tell me what's going on. Typically, it's going to be a sub n minus 1 and then plus your common difference. That is typically how we write recursive rules for arithmetic sequences. So let's go ahead and look at letter A. For letter A, I want to write a rule for the sequence. So this is what I need to find out first. First thing I need to do in order to write my rule is I need to find what D is. What's going on? What are we adding? What are we subtracting each time in order for us to come up with our next value? So I need to find what D is. To go from 2 to 9 and 9 to 16 and 16 to 23, we are adding 7 each time. So because we're adding 7 each time, D is going to be equal to the number 7. Next, in order for me to write an explicit rule, I need an ordered pair. There's a lot of ordered pairs here. Let me show you some choices. 1, 2, 2, 9, 3, 16, 4, 23. How did I come up with those ordered pairs? Well, think about it. 2 is in the first position, 9 is in the second position, 16 is in the third position, 23 is in the fourth position. These are ordered pairs that are of your choice. Which ordered pair looks the easiest to work with? So ordered pairs deal with your term position and the value in that position. I'm going to work with 1, 2 because I think it's the easiest one to work with. So I'm working with 1, 2. I'm going to plug these values. This is n, this is a sub n, and I'm going to plug them into, and then here's my d value. So I'm going to plug them into a sub n is equal to d times n plus b. And from there, I'm going to be able to write my explicit rule. So a sub n is 2. This is equal to d, which is 7, times n, which is 1. And what I don't know is my b value. Now, you're more than welcome to use y minus y1 equals m times x minus x1, which is what we just used in our last chapter. But you do not have to do that at all. I'm open to you just using the b method. So we have 2 is equal to 7 plus b. I'm going to subtract 7 on both sides, and we end up with b is equal to negative 5. So our equation, that's our first thing that we needed to do, was our explicit rule. Our equation is going to be a sub n is equal to 7 times n minus 5. Cool. This is my explicit rule. The second thing that I need to do is I need to identify what value is in the 19th position. So now I'm going to let n equal 19, and I'm going to identify the ordered pair 19 comma something. So I'm going to write a sub n is, a sub 19 is going to be equal to 7 times 19 minus 5. Use your calculator. 7 times 19 is not something that we work with all the time. 7 times 19 minus 5 is equal to 128. So 128 will go into that position. So cool, we found the 19th term is going to be 128. The third thing we need to do is write ourselves a recursive rule. My first term is 2, so I'm going to write a sub 1 is equal to 2. And then in order for me to come up with my next term, I'm going to take my previous term, and I'm going to work with my common difference. I'm going to add 7. And there is your rule. There's nothing more for you to do. Let's go ahead and look at letter B. For letter B, the first thing that we need to do is come up with our common difference to go from 57 to 45 and 45 to 33 and 33 to 21. It looks like we're subtracting 12 each time in order to come up with our next value. So D is equal to negative 12. Next, we need to come up with an ordered pair. Now, you're more than welcome to work with 1 and 57, but it might be helpful for us to work with 1, 2, 3, 4, 21. Why? Because they're relatively smaller numbers. You can work with any of the ordered pairs, however. So I'm going to work with 421 just to show you that you can work with any of them. And I'm going to write a sub n, which is going to be 21, and n is going to be 4. So that's going to be 21 is equal to negative 12 times 4 plus b. So I need to figure out what my b value is so I can write my function. So that's going to be 21 is equal to negative 48 plus b. I'm going to add 48 to both sides. And when I do that, I find that b is equal to 79. I'm sorry, b is equal to, did I do that correctly? So we have 21, that's 48. I think that is 69. There we go. All right, from there, I'm going to write my equation. That's going to be a sub n is equal to negative 12 times n plus 69. There's my equation. That's the first thing I needed to do. The next thing I need to do is I need to let n equal 19 so I can fill out the ordered pair 19 comma something. So that's going to be a sub 19 is equal to negative 12 times 19 plus 69. And I'm simply going to put that into my calculator exactly as I see it. So I have negative 12 times 19 plus 69, and I end up with negative 159. So that's a negative 159 is my 19th term. And then finally, step number 3, I need to write in a recursive rule, which means that I'm going to be working or identifying the fact that my first term is 57. You always need to state what your starting point is, and then your rule. So we have a sub n is equal to a sub n minus 1. That's our previous term. Our next term is going to be equal to our previous term. And our common difference was 12. So we're going to subtract 12. And there's our answer. I want to do letter D in class, so we're just going to do letter C. And if you want to try letter C on your own, feel free to pause the video and try it on your own just to make sure you know what you're doing. But the first thing I'm going to do is identify what my common difference is. Going from 9 to 5 and 5 to 1 and 1 to 3, it looks like we are subtracting 4 each time in order for us to get to our next value, which means our common difference is -4. So now I need to come up with an ordered pair that I would like. And so I like this number 1, and it's in the 3rd position, so I'm going to work with 3, 1. And next, I'm going to substitute these values into my formula. So I'm going to go, this is my a sub n is the number 1, and n is equal to 3. So I'm going to write 1 is equal to -4 times 3 plus b. So I have 1 is equal to -12 plus b, adding 12 to both sides. I end up with b is equal to 13. So my formula, which is my first step, is a sub n is equal to my common difference, which is -4 times n plus 13. Next, I need to find what the 19th term is. So a sub 19, that means that I'm going to let n equal 19, and I need to figure out what that value is going to be. So I'm going to go a sub 19 is equal to -4 times 19 plus 13, and that is equal to -63. So I have my 19th term, so now my step number 3 is to write my recursive rule. So the recursive rule is a sub 1 is equal to 9, so we always state our first term, and then a sub n is equal to a sub n minus 1, that's my next term is equal to my previous term, and then my common difference was a -4, so I'm going to simply subtract 4. Now, the nice thing about an explicit rule is that you can identify any term in any position at any time. That's one of the nice things about the explicit rule. The recursive rule, what's not very nice about it, is that you have to know what came before you find the next. So if you wanted to figure out what the 19th term was using a recursive rule, you would have to know what came in the 18th position before you could find what happened in the 19th position. And sometimes there's a lot of extra work that is unnecessary. So I just wanted to put that out there. Let's go ahead and flip to the next page. We'll talk about letter D next time I see you in class. And in letter A, what we want to do is we want to, I'm giving you a term. I'm giving you an ordered pair. I'm telling you that one term of an arithmetic sequence is a sub 11 is equal to 41. And what that means is that in the 11th position, the number 41 is hanging out there. So the number 41 is in the 11th position. I'm telling you that my common difference is 5, and I want you to write a rule for the nth term, which once again, that language means explicit rule, which means we're going to be working with a sub n is equal to d times n plus b. Well, I have a d, I have an n, I have an a sub n. What I need to do is I need to find what b is. So I'm going to simply go 41 is equal to 5 times 11 plus b. So 5 times 11 I know is 55, so I'm simply going to subtract 55 from both sides. And when I do that, I end up with b is equal to -14. So my equation is a sub n is equal to d, which is 5 times n minus 14. And that is my answer. There's nothing more for me to do. Let's go ahead and look at letter B. For letter B, we have one term of an arithmetic sequence is 15, 100, a sub 15 equals 107. So I'm going to put down 15, 107. This is my n value. This is my a sub n value. My d value is 12, and I need to find what b is because I want to write a rule for the nth term. So I'm going to write down 107 is equal to 12 times 15 plus b. 12 times 15, that is equal to 180. So I have 107 is equal to 180 plus b, subtracting 180 on both sides. I end up with b is equal to -73. So my equation is a sub n is equal to d, which is 12 times n minus 73. And there's my equation. Next, I'm going to give you two terms, which means I'm not going to tell you what D is. I'm not going to tell you what B is. We have to figure out what both of those are. So two terms of an arithmetic sequence are 6, 7, or a sub 6 equals 7, and a sub 22 equals 87, and we want to write a rule for the nth term, which once again means a sub n is equal to d times n plus b. So our first step is we need to find what b is, find what d is. Now remember that d represents our slope, which means that we get to use our slope formula. Remember that slope formula, that's y minus y1 is equal to m times x, our slope formula is y minus talking too fast, y2 minus y1 divided by x2 minus x1. So we have ourselves the ordered pairs 6, 7, and 22, 87. I'm just going to be working with my slope formula. Make sure that looks clean. There we go. And this is supposed to be the number 2. There we go. All right, so D is going to be equal to 87 minus 7 divided by 22 minus 6. So I just rewrote these equations into ordered pairs, and I'm plugging them into my slope formula. And slope, D is our slope, our common difference is our slope. So we have 80 divided by 16, and that is equal to 5. So that is our slope. This is our common difference. Our common difference is 5. The next thing we need to do is we need to find what our B value is. So that means that you get to pick a point. So whatever point makes you feel happy. I would probably work with 6, 7 because it's an easier ordered pair to work with. So we are going to use our point and our D value equaling 5, and we're going to find our B. So I'm going to write 7 is equal to 5 times 6 plus B. And 5 times 6 is 30, so I'm going to subtract 30 on both sides, and I find that B is equal to negative 23. So now that I have my D and I have my B, I'm now going to write my equation, and that's A sub n is equal to 5n minus 23. And finally, I have for letter B, two terms in an arithmetic sequence are A sub 5 equals 91, that is 591 is my ordered pair, and A sub 20 equals 1, so that's going to be 20 comma 1. And we want to write a valid rule for the nth term. So that is another way of simply saying A sub n is equal to D times n plus B. So whenever we're writing rules like that, if I want you to write a recursive rule, I will tell you I want a recursive rule. This other language is just asking you to write an explicit rule. So just keep that in mind. So the first thing that we need to do is we need to find what our D value is. And remember that D is our slope. So that's going to be D equals 1 minus 91 divided by 20 minus 5. 1 minus 91 is negative 90. 20 minus 5 is 15, and negative 90 divided by 15 is negative 6. So that is my common difference. D is equal to negative 6. The next thing I need to do is I need to find what B is. So I need to pick an ordered pair that makes me feel happy inside. If I had to choose between 591 and 21, I'm going to choose 21. This is your choice. You can choose whichever one you want, but I think that 20 and 1 are a little bit easier to work with. My D value is negative 6, and I'm going to plug these values into my formula. So I have 1 is equal to negative 6 times 20 plus B. Negative 6 times 20 is negative 120, so I'm going to add 120 to both sides. And when I do that, I find that my B value is equal to 121. So now that I have my D value and my B value, I'm ready to write my equation, and that is A sub n is equal to negative 6 times n plus 121. And there is my answer. Now this last little box down here is how you can write a rule for an arithmetic sequence, write an explicit rule for an arithmetic sequence. Well, what's really cool about this is that you can write an explicit rule if you know the sequence to start with. But this language down here of A sub n is equal to A sub 1 plus D times n minus 1 requires you to know the first term. And a lot of times you don't know the first term. So in all of these problems that I have given you on this page, you didn't know the first term. So if you wanted to memorize this formula, that's fine. That is just one way for you to eventually get to a sub n is equal to d times n plus b. And this is the formula that I would just prefer you to know, but I want you to be aware that there does exist a way for you to come up with an explicit formula if you are given a sequence. You have to be given a sequence in which you know, this is sequence, in which you know the first term. If you do not know the first term, or you are given and you're given a sequence and you don't know that value, then I would not use this formula. It's not going to help you. Just use the information like I taught you on this page. That is the end of this lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.